So what we're going to do here, I've got a couple of questions for you on the chain rule. I want you to read the questions, pause the video, have a crack at them, and then come back and check you're working against what I'm going to present. So here you go. 3 questions there. I want you to calculate derivatives and differentiate all 3 of them using the chain rule in each case. Pause the video and have a crack. So first one, I want you to calculate the derivative of 3 over 3x plus 2 to the power of 3. Now this sort of question here, what we want to do is we want to write it in the format f of g of x. And in order to do that, I'm actually going to start by writing it as f of x equals 3 bracket 3x plus 2 to the power of negative 3. Now, when you've got one written in this format, there's actually a quite easy and quick way to remember it. Bring the power down, reduce the power by 1, times by the derivative of u. So in this case, I'd have my f dashed equals 3 bracket 3x plus 2. I'd bring down the power, so it's going to be times by negative 3. I'd reduce the power by 1, so negative 3 take away is negative 4. And then I'd multiply by the derivative of what's in the bracket, times by 3 again. So I'd have 3 times negative 3 times 3, so that gives me negative 27. And I've got my bracket here, 3x plus 2 to the negative 4. Let's change that power back to a positive and write it over 3x plus 2 to the power of 4. So there you go, one like that. We can bring it up, write it with a negative in this, and then take it from there. Second question, I want to differentiate cos of sine of x. Now this is one where using a substitution may help. So if we have f of g of x, if we write it in this format here, what we can say is that u is going to equal my g of x, which in this case I'm going to set equal to sine x. Because if we go back to the original, I've got cos of sine x. So the innermost function in this case is the sine x. Something's being done with that, so that's what we set it to be equal to u. Because then, what I can do is rewrite it as f of u equals cos of u. And then what I've got to do is I've got to do f dashed of u times the derivative u dashed. So then, what I can say is fine. So my big derivative f dashed is going to equal derivative of f with respect to u, so f dashed of cos u, which is negative sine u, times the derivative of the u. Now my u is sine x, so in this case that's going to be times cos x. So I've got that there, I've got my cos u, now become a negative sine u, and my cos x there, but look at it, there's still a u in here, so I've got to substitute in to get rid of that. So my overall derivative, f dashed, is going to equal negative sine of sine x times cos x. There you go. There's your final answer for that one. Final question, I want you to find dy by dx for y equals cos squared of 3x. Now this one's actually a bit more interesting because this is a function within a function within another function. If we were to write y in the format of cos of 3x all squared, my innermost function would be the 3x. So I'd essentially have cos of u if I substituted. So if, let's say, I put u equals 3x, I'd then have y equals the cos of u all squared. But then my cos of u is within yet another function, so what I could say is fine. So let's make t equal to cos of u. So then I'd know that my y is equal to t squared. So in order to do this, I've now got to get all of my derivatives and then multiply them all together. So I'd have y equals the derivative of that, so let's do dy by dx. What that's going to equal to start with is I'm going to do dy by dt times dt by du times du by dx. So I'll have my three derivatives, one after the other. So if I've got u there, du by dx, that's going to equal 3. I've got t there in terms of u, so dt by du, if t is cos u, that's going to equal negative sine u. And then my last one, I want dy by dt, so dy by dt in this case is equal to 2t. Now for each of these, I'm then going to substitute back in for the u, the t, and the rest of it, and I'm then going to put it all together so I get my final answer in terms of x. So this one, negative sine u, u is equal to 3x, so that becomes negative sine of 3x. And then 2t, well I know t is equal to cos of u, so that's going to be 2 times cos of u. But again, I can substitute in for the u, so I get 2 cos of 3x. Then I can just stick this all together in one go. So dy by dt, that's going to give me 2 times cos of 3x times the next one, so times negative sine 3x, then times a final derivative times 3. Simplify it all down. What you end up getting is negative 6 cos 3x, put that in a bracket, times sine of 3x. So there you go. That's my derivative at that final stage. So once you've done all of that, broken it down step by step, it's still the same technique. The only difference is we've got one extra function that we need to do and one extra step that we need to do after that. Easy peasy.